in your last session, we have seen about your data pre-processing. In data pre-processing, we have seen what is data pre-processing and what are the four methods of pre-processing. Your four methods are your data cleaning, data integration, data reduction, and data transformation. We have done with data cleaning and data integration. In today's session, we are going to study about your data reduction and data transformation. Now, what do you mean by data reduction? If you are having large amount of data, then to analyze the data, it will become hard. For example, if I have 10 records, to analyze those 10 records, which is easy for me. At the same point of time, if I have 1,000 set of records, is it easy to analyze? No, it takes a lot of time to analyze what is there in the entire table and everything, what information exactly I need and everything. It takes a lot of time. If the volume of data is high, the performance is low. The vice versa. If volume is low, the performance is high. So in data reduction, what we'll do is the volume of data is reduced to make analysis easier. See, in the last class, we have done with this data pre-processing, and these are the four things what we have gone. Today, we have started with your data. See, this process helps in the reduction of volume of the data, which makes the analysis easier, yet produces the same or almost the same result. As I told you, if the volume of data is reduced to make analysis easier. When data is reduced, we can do it in two ways. Already in DBMS, you have heard what is lossy reduction and what is lossless reduction. Lossy reduction is what? Only some of the data will be lost. Whereas in your lossless, no data will be lost, only the data will be compressed. Now, here you have three techniques for your data reduction. The first one is your dimensionality reduction. Now, what does this dimensionality reduction does? It will reduce the number of input variables in the data set, and the large variables will give us what? Poor performance. As we have seen before, if the volume of data is reduced, the analysis is easier and it gives us the what? Almost a similar result or the same result. Now, when I have reduced number of inputs, that is nothing but my dependency is less. When I have more number of inputs, my dependency is more. When my dependency is more, obviously I'll get poor performance. When my dependency is less, I'll get good performance. That is nothing but your dimensionality reduction. Next, coming to your numerosity reduction. Now, here we store only sample data instead of entire data. What do we do in numerosity reduction? We only enter or store only the sample data. Now, for suppose I have student list. For that student list, or a student database, I have 100 records. In that 100 records, I'll just give a sample records, like only 10 students information instead of the entire data. That is nothing but your numerosity reduction. Now, what do you mean by this third one, data compression? Data compression is, see, we all fill the forms, yes or no? They ask us for a signature block, they give us space to keep our photograph, there they give us some size for that. So when my size is more, they give me only 2 KB for signature, 5 KB for photograph. So what do we do? If I have 10 KB of signature, 25 KB of photograph, what do we do? We compress it. When we compress it, we are reducing the data there. That is what is your data compression. This is all about your data reduction. Next, we'll see about your data transformation. What do you mean by data transformation? Your data is transformed into your appropriate forms, which is suitable for mining process. What do? We structure the data or we format the data in such a way that which is suitable for the mining formats. For this, we have four methods for your data transformation. The first one is your smoothing. What do you mean by smoothing? In the previous session, we have studied about binning. In binning, we have seen smoothing, where in handling of your noise. So, here basically smoothing is what? It reduces the incorrect information or it reduces the errors. For such purpose, we use this smoothing. Now then, what is the use of the smoothing here? This smoothing removes what? As I told you, the noise from the data set, which helps to what? Improve the features of the data set. So that is how a smoothing is used. Next is your aggregation. What do you mean by aggregation? In aggregation, the data is stored and it is formatted or presented in a form of a summary. In aggregation, what will happen? Your data is stored and presented in the form of a summary. There will be multiple sources. It takes all the multiple sources, it integrates everything, and that data, whatever it is integrating, it is make sure that it will provide you the accuracy based upon the quantity and as well as quality of the data. What does your aggregation does? From multiple sources, it integrates the data, it checks to provide accurate data by keeping in mind to provide what? Quality and quantitative data. That is your aggregation. Next, coming to your discretization. What do you mean by this discretization? Discretization is nothing but it splits into small intervals. What do you mean by intervals? For example, I have a raw data like 10, 12, 13, 14, 21, 28, 32, 44. I have a series like this. So, to small intervals, how do I divide it? From 10 to 20, one interval. From 21 to 30, the other interval. From 31 to 40, other interval. As I have till 44, I'll make it as from 44 to 50 as one interval. So, the raw data, completely the series of numbers like my 10, 12, 18, 22, 24, 32, 38, 44, all these numbers, the raw data, I am making that raw data into small intervals. That is nothing but your discretization. Next is your normalization. What do you do in normalization? Already you have done normalization in your database management system, in your DBMS. What did you do? Your normalization is basically used to reduce the redundancy. Yes or no? For redundancy, we use the normalization. So it is done in order to what? Scale the data values in the specified range. Now, in the specified ranges from -1 to +1, from 1 to 10, or from 100 to 1000. So, this ranges, a specific range would be given. That is nothing but your normalization. So, this is about your data pre-processing. In your data pre-processing, we have seen about your data cleaning, data integration in the last class. In today's session, we have seen about your data reduction and your data transformation. Your data reduction is nothing but a large amount of data is analyzed, which is very harder to break it down or to compile it. So that's the reason we go for data reduction. So the large volume of data gives me what? Low performance, whereas the low volume of data gives me the highest result or highest performance. Here we have seen about your dimensionality, we have seen about your numerosity. These are the things we have seen in your data reduction. Coming to your your transformation is nothing but what? You have a format or the structure. For that, you transform it with a suitable data mining process. Here again, you have four methods. Those are your smoothing, aggregation, discretization, and normalization. This is about your data pre-processing. Next, we are going to study about KDD. Your KDD stands for knowledge discovery from data. Knowledge discovery from data. Basing upon your data pre-processing techniques, we build knowledge discovery from data. In KDD, what is happening? You have got two images here on the screen. You can check with the right image. See, what is happening? The process goes on like this in the data, in your data mining KDD process. You have a raw data. That raw data would be next moves upon to your data pre-processing. From data pre-processing, it moves on to your data mining. From data mining, it goes on to your data post-processing. Then you will get a knowledge. Now, coming upon to your databases. Now, what do you have in the databases? You have raw fact. It's data. Data is nothing but a raw fact, right? In the databases, you have multiple different types of data which are there in the databases. Here you can see they have given the examples of a flat files. You can have a relational databases. You can have a transactional databases. Whatever the databases you have it in the database. So now, from this database to move upon to your data warehouse, it has to perform cleaning and integration data pre-processing techniques. Now, what do you mean by cleaning? In cleaning, basically it checks whether the data is inconsistent, whether we need to correct any data, or you have any noisy information. Can we do anything in the cleaning section? Next, coming to the integration, what does your integration does? You have multiple sources of data. All that multiple sources of data combined together, they integrate together to the understandable language or the understandable knowledge to the user. So from that, it moves on to what? Your data warehouse. From data warehouse to move upon to your data mining, then again data pre-processing techniques are performed. Those are your selection and your transformation. What does your selection does? It checks what data is to be selected and what information has to be selected from that data warehouse, and everything goes on with the selection. Coming to the transformation, what do we do in transformation? It consolidates the data into what? Appropriate format. For what? To perform any data mining tasks. So from that, it moves on to the data mining. Data from data mining, where it is going, it is generating a pattern. How in data mining? Here we apply different methods like your decision trees or your algorithms, whatever it is, we apply on the data mining techniques. From that, based upon those algorithms, it moves on to the next. It shows in the form of what? Patterns. This patterns, that is nothing but your evaluation and presentation, comes under your data post processing. Your pre-processing is what? Your cleaning, integration, selection, and transformation. After data mining, it moves on to your post processing. So post processing, it is evaluating and presenting. How is it evaluating? Based upon the data. Now the data is all in the form of a numbers. So to visualize to the user, a layman can also understand if I represent in the form of a visual structure. It might be the bar charts, or it might be the pie diagrams, or any diagrams or graphical representations, anything. That is nothing but your knowledge. This is all about your KDD process. Your KDD process undergoes what? A raw data. Raw data is converted using your data pre-processing. From all the pre-processing techniques, it goes on to the data mining. From data mining, using the data post-processing, it gives us what? The final result as your knowledge. You all can see here data cleaning to remove noise and inconsistent data, integration where multiple data sources may be combined, data selection where data relevant to the analysis tasks are retrieved from the database, data transformation where data is transformed and consolidated into forms and it is appropriate for mining by performing summary or aggregation operations. Next, data mining, an essential process where intelligent methods are applied to extract data patterns. Next, your pattern evaluation to identify the truly interesting patterns representing knowledge based on interestingness measures. Next, your knowledge representation, where visualization and knowledge representation techniques are used to present minded knowledge to users. This is all about your KDD. Thank you.